So we are on to the second to the last section of this chapter, which is talking about equivalent ratios. Equivalent means equal to, and proportions are two equal fractions. So an example of a proportion would be 2/4 equals 1/2. Two equal fractions set equal to each other. That is a proportion, and that's what we're going to be working with for the last two sections. The first one we're going to be dealing with is, are these equivalent fractions? And there's three ways to do it, or two big ways to do it, and then one other way. The easiest would be to take these two things and then figure out how they get from one place to the other. So if we go from 2 to 6, that's multiplying by 3. So if we go from 7 to 21 and we multiply by 3, which we do, then those are equivalent to each other. Now that's one way to do it. Now, another way that takes a little bit longer, but it's actually a lot easier over time, is what we call cross multiplication. And cross multiplication is you draw an X through your equal sign and you multiply across the X. So the top left and the bottom right get multiplied. 2 times 21 is equal to 42, and 7 times 6 is equal to 42. If these two things match up, which they do here, then yes, they are equivalent. Okay? The other way to do it, and we're not going to do it this way because we're not using calculators right now, is you would do 2 divided by 7, and that gives you a decimal, 0.2857, and then you do 6 divided by 21, and if that equals the same decimal, which it does here, then they're also equivalent. Now, the way that a lot of you are going to like, the going from 2 to 6, multiplying by 3, 7 to 21, that's a really nice method, except on the bottom types of problems here, because there is no way to get from 8 to 6. So here, we're going to have to do cross multiplication. So we do 8 times 20, that's equal to 160, and then we'll have to do 24 times 6, and we'll have to do it this way. $144. So these are not equivalent ratios. Okay, one big thing with these types of cross multiplication problems, this does not mean the same thing as when you have fractions multiplied. So the difference between this problem and this problem is there's no equal sign. So for cross multiplication, there must be an equal sign. And we'll say that like 100 times over the next couple days. Must be an equal sign for cross multiplication. Okay? For these same types of problems, if you have positive or negatives built in, it means the same thing. So we do this. Negative 3 times 25. That's negative 75. 5 times negative 15. That is also negative 75. So yes, these are equivalent ratios or a proportion. Down here on the bottom, negative 4 times 6. That's negative 24. 7 times negative 5. That's negative 35. So no, these are not equivalent ratios. Okay, once again, because we put that equal sign in the middle, that's why we can do cross multiplication. So finding 3 equivalent ratios. I'll do the top one. I expect you to do the bottom. There's 2 ways to do it. You can either simplify down. So like for this one, dividing by 2 would give us 4/7. That is an equivalent ratio. You could also multiply by a number. So if we multiply by 2 on the top, that becomes 16. Multiply by 2 on the bottom, that becomes 28. We could multiply that by 2 again to give us 32/56. There's literally an infinite number of ways to find equivalent ratios for these problems. So I want you to try to find 3 equivalent ratios for the bottom one. Some examples here could be 2 over 9, 6 over 27, 8 over 36, 16 over 72. Millions upon millions of options that you could have picked for these numbers. Those are just some of them that would work. And that, I would like you to look at this fraction here, 3/4, and tell me which of these numbers are equivalent to 3/4. Okay, the answer to this one is 6 over 8 and 12 over 16. Those are the two that are equivalent. Okay, this one's not equivalent because there's a negative in the fraction, and this one's not equivalent because we multiplied by 2 to get to 8, and 3 times 2 is not equal to 2. So that one doesn't work, and that one doesn't work. All right, if you have questions on any of this stuff, please don't hesitate to ask. And there are 2 assignments, I think, posted online for this one.